So students, see, in previous class we are discussing that objective problems. It is becoming late, so we need to finish them fast. Yeah. So here is your objective questions. Question number 36, Nana. Question number 36 is there. Now, see question number 36. What they have given, Nana? If intensity ratio of two interfering waves is 9:1, then ratio of maximum to minimum amplitudes of the resultant wave is maximum to minimum amplitudes of resultant wave is they're asking. Okay, intensity ratio given, Nana. I'm giving hint. You need to solve. Okay, I1 upon I2 value they have given, that is 9/1. They're asking ratio of maximum to minimum amplitudes. Okay, amplitude maximum to amplitude minimum they are asking. Maximum amplitude minimum amplitude formula is A1 plus A2, Nana. Whole square is maximum amplitude. Minimum amplitude will be A1 minus A2 whole square. Because I maximum is equal to root I1 plus root I2 whole square. No, do you remember this? And we know I is proportional to A square. Then root I is proportional to what, Nana? A. That's why I am replacing root I with A. That's it. Clear? Yes, this is the formula we need to use. Are you understanding? Yes. So I1, I2 given. That means nothing but A1 square by A2 square is given. That implies what is A1 by A2, Nana? A1 by A2 will be 3:1. No, square them. Square this to get A1, A2. You will get 3:1. No, substitute here. 3 plus 1 is 4. 4 square by 3 minus 1 is 2. 2 square. How much the answer? 4 square is 16. 2 square is 4. 4 4 is 16. Yes. So 4:1 it is. No? Yes or no? Yes, 3 plus 1 is 4. 4 square is 16, no? Yes. 2 square is 4. 4 4 is 16. Option, what happened? If the intensity of ratio of two interfering waves is 9:1, intensity ratio they have given I1, I2. 9:1 they have given. One more time, let us see. I1, I2 given, Nana. I1, I2 given 9:1. As we know, I1 is nothing but A1 square, I2 is nothing but A2 square. So these values are 9/1. Okay. Then what is A1 by A2? A1 by A2 will be 3/1. Correct? Yes. Under root it will become, no? Yeah. Now then they're asking ratio of maximum to minimum amplitude. Yes. A maximum amplitude by A minimum amplitude they are asking. Okay. Question number 36 it is. Okay. Yeah. So maximum amplitude to minimum amplitude they are asking. Okay. Maximum amplitude how much? A1 plus A2. Minimum amplitude is A1 minus A2. Yes, yes. So A1 plus A2 is 3 plus 1. A1 minus A2 is 3 minus 1. Yes. So 4/2. 3 is 2/1, Nana. Yes. Option 1, Nana. See, why is previously I given square? No, see, A resultant intensity square is equal to A1 square plus A2 square plus 2A1 A2 cos phi. No? Yes or no? This is the formula. Correct? For maximum value, cos phi value should be 1. Means it will be A1 square plus A2 square plus 2A1 A2. It will be in the form of A1 plus A2 whole square. No? Yes or no? So this square cancel. We get A maximum comes out to be A1 plus A2, Nana. Yes. So that's why I have written A1 plus A2. And minimum will be A1 minus A2. So 3 plus 1 by 3 minus 1. 4/2. 2/1 is the answer. Option 1 is right answer. Did you got students? Clear? So question number 36, option 1 is right answer. Next, question number 37. For coherent sources, which is essential condition? See, very important thing for coherent sources is phase difference should be same. Okay, delta phi should be same. Then only they are said to be coherent sources. color difference wrong, amplitude difference wrong, velocity difference wrong, amplitude difference wrong, color difference is wrong. 5 should be same. Okay, then only they are called as coherent sources. So 37 option 2 is right answer. Okay, next question number 38. When exposed to sunlight, thin film of oil on water often exhibits brilliant colors. S. Due to the phenomena of interference. Important for your competitive exams. Easy question. Okay, next. I1, I2 value 9:1 they have given. Then I maximum to I minimum what? Yes, easy question. I max by I minimum. This type of questions are repeating, no? You need to remember, repeating means they are important. Root I1 plus root I2 whole square upon root I1 minus root I2 whole square. Okay. So I1 by I2 is 9:1. Root I1 is to root I2 will become 3:1, no? Yeah. So it will be 3 plus 1 by 3 minus 1. This square, this square. 3 plus 1 is 4. 4 square is 16. 3 minus 1 is 2. 2 square is 4. So it will be 4 by 1. Yes. Option 3 is right answer. Got it? This type of questions are repeating. Means they are important. Clear? Even though they are repeating, I am discussing because they are important. This type of questions you will get for NEET students. Next question number 39 is over. Question number 40 no. Question number 40. What they have given? Question number 40. A soap bubble appears color due to the phenomena of. Due to which phenomena this soap bubble appears colors? Main reason is due to interference, and that too by division of amplitudes. Amplitude will divide there. So this is the reason for the appearance of the colors of the soap bubble. This is also important conceptual question. You need to remember this. Okay, na? Clear? Next question number 41. Let us go to question number 41. See what they are given. Two coherent light sources emit light of coherent sources, they said. So if they are coherent sources, they should emit light of same frequency or constant phase difference. Correct? Yes. So same frequency and constant phase difference. Same intensity, wrong. Different frequency, wrong. Constant phase difference, okay. But different wavelength, they said. So wrong. Different wavelength, they said. Wrong. So same frequency having constant phase difference. Yes. Fourth option is right answer. Getting? Next. 42. Now we are entering into YDSC experiment. Very important. On this topic, you are getting so many questions. Yes, JEE students, you also have to need to be very careful with these points. Okay. In Young's double slit experiment, if amplitude of interwaves are unequal, then what happened to the fringes? Constant in the fringes decreases, constant in the fringes increases, number of fringes increases, number of fringes decreases. See, if amplitudes is unequal, if amplitudes are equal in a YDSC experiment, then fringes will be of equal intensity. If unequal amplitudes are there, intensity depends upon amplitude, no? Yes. If unequal amplitudes are there, then intensity of the bright and dark fringes will be not exact bright, not exact dark. Due to that, there will be some contraction, some blurriness will be there. Okay. So constant in the fringes increases. This is the reason. Sorry. Contract in the fringes decreases. This is the reason. Okay. Clear? Yes. Next. Question number 43. Question number 43. What they have given? Question number 43. Question number 43. Read. YDSC experiment proves that which of the following fact? So YDSC experiment proves wave theory, wave nature of light. Okay, light made up of particle is wrong. Light made up of waves. Yes, it is correct. Okay. YDSC experiment proves that light is made up of waves. Clear? And option 3, light is made up of neither waves not particle, wrong. Fringe width doesn't depends upon spacing between the slits. Wrong it is. So YDSA experiment proves light has wave nature. Remember this. YDSC experiment and diffraction experiment, both Fresnel diffraction, Fraunhofer diffraction, both these experiments proves wave nature of light. Okay, remember the point. Next, question number 44. Which of the following statement is true? True statement we need to find. In YDSC experiment, separation between the slits is gradually increases. Separation between the slits is increases gradually. Means separation between the slits means small d is increasing. Then what happened? Fringe width increases and fringes disappear. So fringe width formula what na? Fringe width formula is lambda capital D by small d. Do you remember this? Yes. Can you see? I'll write one more time. Fringe width beta is equal to lambda capital D by small d. Correct? Yes. So as small d is increasing, with this denominator increases, then fringe width decreases. No? Yes. They are saying that fringe width is increasing. So wrong. Next, width decreases. Yes. Fringes disappear. Yes. Option 2 is that answer. Fringes become blurred. No. Fringes width remains constant. Wrong. So option 2 is right answer. Question number 44. Conceptual question. Question number 44. Option 2 is right answer. Clear? Next, question number 45. Question number 45. They have given that. Question number 45. Question number 45. In Young's double slit experiment, what happened? Only interference occurred. Yes, Young's double slit experiment, interference occurred. One more thing, only diffraction occurred? No, diffraction. Only diffraction doesn't occur. Both interference and diffraction occur. Yes, this is the right answer. Okay, only interference not occurs. Diffraction also occurs. 44 important questions. Student will get confusion with this. Why, sir? See here. Let us imagine these are the two slits. Small holes. These are slit 1 and slit 2. And here there is a screen at a distance of capital D. Clear? Yes. So wave will come from this and wave will come from this, and they will interfere here due to interference. One point. And second point is, as this slit, each and every point on this wavefront acts like a different source to produce. Okay. So this source will diffract. Due to that diffraction also fringes will occur. Important point. Students will think that in YDSC experiment only interference will occur. No, in YDSC both will occur, interference and diffraction. Important, you need to remember this. Question number 45. Conceptually important question, remember it. Okay, na? Clear? Yeah. See, 18 students are there. What is the use if you join like this? Very less members. Question number 46. In Young's double slit experiment, one of the slit is so painted that intensity of light emitted from it is half of the light emitted from the other slit. Okay. Now in Young's double slit experiment, what they are saying that two slits will be there. No, here slit S1, slit S2. Now for one slit, they have coated with one paint. So that due to this coating, intensity become half, whereas the intensity is I only, let us imagine. Now due to that, what will happen? Fringes will disappear. No, fringes doesn't disappear. Next, bright fringes will become brighter. No, bright fringes, intensity should decrease. No, next, both bright and dark fringes will become dark. No. Dark fringes become less dark and bright fringes become less bright. Yes, this is the answer. Yes. So when intensities are different, resultant intensity will decrease. No, less intensity will become. Whereas dark also it will become less dark because of this reason. Are you understanding? Option 4 is right answer, Anna. Don't get confusion. Okay. Option 4 is right answer for this. Next, question number 47. In which, in white light interference, nearest to central fringe will have the which of the following color is? Question is important. So many times repeated for NEET and JEE both. See, student will do mistake here. What they are asking? They are not asking which maxima will form, which color maxima will form, or which color minima will form. They are asking just which color will form. They are asking. Clear? Okay. Okay. So what they are saying, in white light interference, white light is incident on the two slits nearest to central bright fringe, which have the following colors. Nearer to that central bright fringe, which color will be there? This is your question. Clear? Yeah. So wait, I'll share whiteboard so that you will understand clearly. Okay. See here, students. Here, this is a YDST experiment I am drawing. This slit S1, this slit S2. Here source will be there. It will send light. Clear? Yes. Here at a distance of capital D, here you will have a screen. Okay. Now these two will interfere here to form a central bright fringe. Clear? Yes. Is there any option to change the color? Yes, here is it. Okay. Central bright fringe will form here. Okay. Now this central bright fringe, nearer to this central bright fringe, some different colors will form now. So what are that colors we need to find? Yeah. So this is central bright fringe. First we know that fringe width formula what is? Fringe width is equal to n lambda, yes, not n, lambda capital D by small d. Means here this fringe width depends upon lambda, correct? Yes. And one more thing, from here if you go upward of distance y, maxima where it will form? No, maxima will form from for n lambda. Minima will form for 2n minus 1 into 2n plus 1 into lambda by 2. Clear? Yes. See, maxima will form for a light of higher wavelength. See, we have VIBGR colors. 7 colors. This lambda of red is maximum, you know. Yes, wavelength is increases as you are going down. Okay, and VIBGR violet is having lambda minimum, you know. Clear? Yes. See here, from this central maxima, if you go up, maxima will form here, red color maxima will form here. Down to that, which one will form? Less wavelength. Down to that, orange color will form. Clear? Orange. Then last one, violet color will be there. So before violet, blue indigo. Blue color will be there now. From central maxima, first blue color will be there. Blue color maxima will be there first. Are you understanding this? Next, green color will be there. Next, yellow color will be there. Last, orange, red color will be there. Last, maxima I am talking. Color maxima will be here. Okay. Then what about minimas? Which minima will form first? Same thing. Minima also directly proportional to lambda. Are you understanding what I am saying? Clear? Minima also directly proportional to y. Minima is also directly proportional to lambda. So which minima will form first? Red color minima forms first. Are you understanding? Yes. Sorry, wavelength is less. That minima will form first. So which color is having minima? Which color is having least wavelength among that VIBGR colors? Among VIBGR colors, least wavelength is for blue. So blue color minima will form first. Are you understanding? Yes. So wavelength is less. So that minima will form first. Blue color minima will form first. So as blue color minima is forming there, alternatively red color will appear there. Are you understanding? From central maxima, here blue minima is forming. Blue minima is forming means which is dominating there. Alternatively, red color will appear. Are you understanding? So exactly after first minima, first color appears will be red color. Okay, and if the question is which color maxima will form first, which color maxima will form first means blue color maxima will form first. Okay, don't get confusion that question. Okay, so what is the question, Anna? Yes, we will go to that question. Yeah, question is, yes, 47th question. 47, question number 47. In white light interference nearer to central bright fringe, which of the following color will appear? Red color will appear. Very important question, you need to remember this. Which color will appear? Red color will appear. Why red color? Because near to central maxima, blue color minima will form first. Cannot? That is the reason. Important point, remember this. That's why I'm stretching more on that point. Next, question number 48. In Young's experiment for white light source, if XMR and XMV denote distance of nth bright and violet fringe. Okay, distance of bright fringe, maxima fringe is n lambda capital D by small d. No, yes. So this distance, y distance directly proportional to wavelength lambda. Okay, more is the wavelength, more will be the distance y. Clear? Yes, means red color wavelength is more. Are you understanding? Red color wavelength is more. Red color wavelength is more. So distance of red color will be more compared to violet color wavelength. So option will be XMR should be greater than XMV. See question. Distance denote distance of nth red. XMV and XMR denotes distance of nth red and violet fringe. Which fringe will form first? Which is having highest wavelength, that fringe will form first. Distance of that distance will be more. So due to that more distance, red color distance will be more than violet color. So 48th answer is right answer. Clear? Next question number 49. Question number 49. What they have given? Conceptual question, and these are conceptual questions. You need to remember these are. Question number 49. Yeah. So for question number 49, they have given in YDSC experiment, wavelength of light is 6000 angstrom. Then phase difference between light reaching the third bright fringe from the central maxima. So as we know that the path difference for third bright fringe is equal to 3 lambda. Do you know? Yes. So path difference for bright fringes is n lambda. For dark fringes is 2n minus 1 into lambda by 2. You have to remember that. So because they are saying third bright, so I am writing 3 lambda. And we know phase difference and path difference relation is delta phi. Phase difference delta phi is equal to 2 pi by lambda into delta x. Yes. So 2 pi by lambda into delta x is 3 lambda given. Correct? Yes. Lambda cancel. How much you are getting, Nana? 6 pi. Means phase difference is 6 pi. Yes. Answer yes. Option 4 is right answer. They are given wavelength also, but this wavelength is of no use. Don't get confusion. Just they are saying that what is the phase difference between light waves reaching third bright fringe from central maxima. So for third bright fringe, what is the path difference? Just find. Path difference for third bright fringe is n lambda. As we know, path difference for nth bright fringe is n lambda. Bright fringe is n lambda. Third bright fringe means 3 lambda. Now they are asking phase difference. So phase difference and path difference relation I am writing. From this relation I will get 6 pi. So 6 pi is the answer. Clear? Next. Question number 50. They are given that if intensity of each wave in the observed interference pattern in YDSC experiment is I0. each wave intensity is I naught. Then at some point P, where the phase difference phi is, what is the intensity at some point where phase difference is I? They're asking, okay? Yeah. So for that, see, they're asking, they're asking two intensities given, na? I1 is I naught given and I2 is also I naught given. So what is the resultant intensity? Resultant intensity is how much, Nana? I1 plus I2 plus under root of, sorry, 2 into under root of I1, I2 cos of angle between them. Okay. So I1 value is given I0 plus I2 also given I0 plus 2 times of I0 cos phi. Correct? Yes. So I0 plus I0 is 2 I0 plus 2 times of I0 square root. It will become I0 cos phi. Correct? Yes. So 2 I0 take common, you will get 1 plus cos phi. Yes. So resultant intensity we can do like this. Or else we can write it as 4 I0 cos square phi by 2. This is also we can write. Remember both the result. I have already explained this point. Clear? Yeah. So let us go to that question. Question is, yeah. So if the intensity of each wave in the observed interference pattern in YDS experiment is I naught, then at some point P where phase difference is phi, intensity I will be how much? Intensity I will be how much they are asking, okay? Yes. So intensity I will be 2 I naught into 1 plus cos phi nana. 2 I naught into 1 plus cos phi. Understood, no? Clear? So this is the answer. Just now I have shown you that derivation. How we will get. Next, in YDSC experiment, fringes are of, all the fringes are of equal width and equal intensity. Nana. Important. YDSC experiment, all the fringes are of equal width and equal intensity. This option 3 is right answer. Whereas in diffraction phenomena, central fringe will be double the width and double intensity, whereas remaining fringe width will be unequal width and unequal intensities in diffraction. Whereas in interference, all the fringes are of equal width and equal intensities. Differences you need to remember. It is important. Clear? Yes. Next. Question number 52. Question number 52. What they have given? See. In Young's experiment, monochromatic light means single frequency or single wavelength light through a single slit S is used to illuminate two slits S1 and S2. Okay. Interference fringes are obtained on a screen. Okay. The fringe width is found to be W. Okay. So fringe width they are saying that is equal to W. They are saying. So it is nothing but lambda capital D by small d. Clear? Yes. Now what they are saying? Now see question is important. Now a thin sheet of mica having some refractive index is placed near and in front of one of the slits. Now fringe width becomes what? Fringe width is W dash. Fringe width becomes W dash. Means here two slits are there, like this, two small holes are there, and here screen is there, capital D. This is the sewer, this is your screen, capital D. Okay. This is the small d distance between these two. Now what they are saying, in front of one of the slit, they are keeping one sheet, plain sheet. They are keeping. Due to this, what will happen to fringe width? They are asking. See, fringe width depends upon lambda, capital D, and small d. As in this experiment, we are not changing capital D, small d, we are not changing capital D, and we are not changing the wavelength of light that is incident on the slits. Okay, due to that reason, fringe width will not change. Remember, important point. Student will get confusion this only. In previous classes, I told you that these fringes will shift upward by some distance. The distance is mu minus 1 into lambda capital D by small d, this much into t. This much it will shift up, I told you. but fringe width of each fringe, this width doesn't change. Are you understanding? So important question. Remember, student will give this only. They will say that it will become mu minus 1 into t into lambda. It is wrong. It will be remain same. Important point. Okay, students understanding? No, very important point. Remember that. Next, question number 53. They have given that in Young's double slit experiment, two slits acts as coherent sources of equal amplitude. Okay, amplitudes are equal and wavelength lambda. Okay. In another experiment with the same setup, setup is same. Setup same means capital D same, small d also same. Two slits are sources of equal amplitude again A and wavelength lambda, but are incoherent. The two sources are incoherent. First they are coherent sources. They are coherent sources. Now they are incoherent sources. Ratio of intensity of light at the midpoint of the screen. So intensity of light due to coherent source is 4 I naught nana. Intensity of light due to incoherent source will be 2 I naught nana. This you need to remember, important point. So its ratio will become 2 by 1. So it will be 2:1. Point is important, remember. For coherent sources, it will be 4 I naught. You know that resultant intensity is equal to 4 I naught cos square delta phi by 2 I have given. No, yes. Coherent sources means delta phi is 0, cos 0 is 1, so cos square 0 is 1, so it will be 4 I naught. Whereas for incoherent sources, delta phi value is 90 degrees. Cos 90 keep here. 90 by 2 means 45. Cos 45 is 1 by root 2. 1 by root 2 whole square is there here. 1 by root 2 whole square is 1 by 2. So it will become 1 by 2 means 2i. So that's why I written 2i. Got it? So it will be 2:1. This is also a somewhat important question for JEE students also. And this is also for JEE students. Conceptual question important. You need to remember. So question number 53, option 2 is right answer. Students, are you getting clear? Next, question number 54. In Young's double slit experiment, if the width of the slits are in the ratio of 4:1, two slits will be there, no, in this, like this. Two slits will be there, no. This slit S1, slit S2, their width they are given W1, W2. Their ratio given W1 by W2 is equal to how much given? 4 by 9. Then ratio of intensity of maxima to minima. See Nana, intensity of light is directly proportional to width of the slit. This width is more, then intensity will be more coming from this slit. So intensity is directly proportional to width. That means I1 by I2 we can write it as 4 by 9. And we know ratio of I maximum by I minimum ratio we know. That is root I1 plus root I2 whole square by root I1 minus root I2 whole square formula. Substitute these values in this, you will get the answer. Okay. Question number, what is the question number, Nana? Question number 54. Question number 54, option 25:1, Nana, you will get, find that. Easy question. Okay. An important point. Here one more point we came across, that is intensity is directly proportional to width of the slits. Next. 55. In interference experiment, the spacing between the successive maxima or minima. Says spacing between successive maxima or minima is nothing but fringe width, and the fringe width formula is lambda capital D by small d. Lambda capital D by small d is here. Option 2 is right answer. Spacing between successive maxima or minima is called as fringe width. So lambda capital D by small d it is. Next, Young's experiment is performed in air and then performed in water. Then fringe width, what will happen? Fringe width is directly proportional to wavelength. If a experiment is set up is placed in water, wavelength will get reduced in water. No. Yes, so due to that, fringe width will decrease, Nana. Remember, point is important. So wavelength in water is wavelength in air by refractive index of water. So it will get reduced. Due to that, fringe width also reduce. Option 2, important for NEET students and JEE students. NEET and JEE, both the students, it is important question. They are asking this type of questions repeatedly. They are asked to find the value also. You should be in a position to find the value also. Questions will be there, I will show you. Next, in Young's experiment, one slit is covered with blue filter and other with yellow filter. One is with blue, another with yellow. Then interference pattern will be. So both the colors are different. Phase difference will become not constant value. So due to that, they will not form. Okay, they fringes will never form if we use different colors for two slits. Condition is monochromatic light should be there, no, that is a reason. Got it? Yes. So 57 questions over, Nana. Still so many questions are there. So some questions you need to solve them homework. Some questions I'll give you homework, you need to solve them. Okay, na? Yeah. So this is for today's class. Let us stop this meeting. Okay, thank you.